Okay, so we are going to do a quick review of everything on systems of linear equations, but specifically I'm just going to focus on two equations and two variables in this video just to keep it a little shorter. Okay, so first of all, what am I talking about when I refer to a system? So systems are things that look like this. So you'll have like two equations with two variables. And that is what this video is about. So of course you could have more equations, more variables, but to keep this video shorter, we're just going to restrict ourselves to situations like this. Doesn't have to be X and Y, it could be other letters, of course, but this is kind of the situation. So there are three ways to solve systems of linear equations. So the first way is by graphing, which is typically you find the intersection. Then there is the substitution method, and then there is the elimination method. So I am going to go through all three of these very quickly in this video. I assume that you've probably seen this at some time, but you just kind of needed to fill in the details. So let's get into this. So graphing, I think, is pretty self-explanatory if you know how to graph. So for this example, I just have two equations and I have a graph. So this is a little bit of like a context specific thing. It would require that you actually have kind of graph paper in front of you, but and also would it really require that the two equations can be easily graphed. And these two are kind of the perfect candidates to be easily graphed. So for this first one, so I'm going to graph it in blue, and I am assuming that you do know how to graph. If you forgot all of that, I do have a review video on lines, so I highly recommend you check that out. But for this one, this is in slope-intercept form. So my y-intercept is 2, and then my slope is 1. So I'm going to go up 1 and over 1. And so one of the things with graphing is that sometimes it's helpful just to sketch out a few points because it might make it easier to figure out where that point of intersection is. So I haven't actually worked this out in advance, so we'll just kind of see how this goes and see. I might make my point on this. So for this other one, I'll do it in this gold color. So my y-intercept here is going to be 1, 2, 3, 4. And then my slope is now -1. So I'm going to go down 1 and over 1. Cool. And that worked out great. Down 1 over 1 and then down 1 over 1. Okay. So this is kind of the ideal. The ideal is that you graph enough points so that you have this nice clear intersection point that you can find. Not every graph works like this, so this is a little bit context specific, but in this case I can pretty easily tell what this point is. So this is the point 1, 3. Now, after you think you've found your point with graphing, so the thing with graphing is that sometimes you might not draw something perfectly to scale, and so when that happens, you want to just double check your answer real quick. So to check if something is true with a system of equation, you just plug it back into both equations, okay? So let's start with the first one, so I'll just do it in blue. So this is going to be 1 plus 2, does that equal 3? Yes, that equals 3. And then for the other one, this was 4 minus 1, that also equals 3. So there are the two equations with this point plugged in. They are both true, so we're good to go. So that's graphing in a nutshell. So next, let's discuss the substitution method. So I've got this problem here, 2x plus y equals 3 and 4x minus y equals 9. So for this one, so what we're going to do is we're going to look at the equations and we solve for whichever variable looks like it's easiest to solve for. So it doesn't matter if it's x or y, but what I noticed is that this y looks like it's going to be the easiest to solve for, and so that's what I'm going to do. So I'm going to go ahead and I'm going to subtract off this 2x so that I get y, let's see, I'll go this way, y equals 3 minus 2x. Okay, so I really easily solve for y. And then after you have done that, what you're going to do is you're going to take this equation and you're going to plug it in where there is that variable in the other equation. So now this is going to turn into 4x minus 3 minus 2x, right? Because we said that that's what y equals. And so I just plug that into the equation like so. And now look what I've got. Now I have an equation in one variable, and so I can go ahead and solve this. So this becomes 4x minus 3 plus 2x equals 9. So I get 6x minus 3 equals 9. Add 3 to both sides to get 6x equals 12. Divide both sides by 6 to get x equals 2. Okay, So after you solve this for one variable, you plug this back into either equation to solve for the other one. Doesn't matter which one you want to plug it into. So I'm going to plug it into the first one. So this is going to become 2 times 2 plus y equals 3. So this is 4 plus y equals 3. And we can subtract this off to get y equals -1. So my solution in this case would be, the xy coordinates. So it's going to be 2, -1. And so once again, we can really easily check that. So giving myself just a little bit of space here, so let's check this real quick. So I can take 2 times 2 plus -1, so let's see if that's going to equal 3. So this becomes 4 minus 1, so that does equal 3. Sorry, I think I said -3, I meant 3. Okay, so the first one checks out, and then plugging this into the second equation, so this becomes 4 times 2 minus -1, so this is 8 plus 1, so yes, that equals 9. So that is definitely the solution, and that is what you are looking for when you are solving a system of equations. You can always check to make sure that it's right. Okay, and the last technique that we're going to talk about is elimination. So actually, the last example we could have totally done elimination on, but this is an ideal example also for elimination. So ideally, what would happen with elimination is that you have this relationship here. So it's not that it has anything to do with which letter we're talking about. It's about the idea that this and this are like opposites of one another. So this could be anything that you wanted. This could be -7y as long as this were 7y. So like they have to be the plus and minus of one another. So the idea is that if you were to add these together, they would equal 0. So when this happens, then we can use elimination. And so what we're going to do actually is we're just going to add these equations straight down. And so what ends up happening, the y's drop out, and I'm left with 5x equals 15. And so then from there, I actually just finished solving for x. So I can divide both sides by 5 to get x equals 3. And after I have found that solution, then I can plug it back in. So I'm going to plug this back into the first equation. So this becomes 2 times 3 minus y equals 6. So I get 6 minus y equals 6. And then I can go ahead and subtract this off to get minus y equals 0. So that means that y just equals 0. So my solution in this case would be 3, 0. And you can pretty easily take this and just check it in both equations to make sure that it's right. You know, I'm the omniscient math teacher for this, so I know that it's going to work, so we're all good. Now, the thing with elimination is that it doesn't always work out so nicely. So here is a great example of something that could happen with something that would be good for elimination, but it requires a little more work. Okay, so sometimes when you have a system like we have here, things may not just automatically cancel out, so you have to manipulate an equation then. So one thing that you are allowed to do is you can manipulate one or both equations by multiplying the entire equation by a number. And so in this case, what I notice is that I've got 8y and -4y. And if I could just multiply this by 2, then I could go ahead and use the elimination method. So what I'm going to do is I am just going to go ahead and do that then. I'm going to multiply this by 2. And what I want to do is I want to just keep everything nice and neat. So I'm going to restate my system here. So there's my first equation. And now I'm going to restate the second equation having multiplied by 2. And now I can go ahead and add everything together and just use the elimination method. But what you're going to find here is, so now I've got 4x minus 4x, so that's 0. 8y minus 8y, also 0. And oops, I forgot to multiply this by 2, didn't I? Sorry, my bad. And -24 plus 24, also 0. So this is another result that you can get with a system. So I get 0 equals 0. Now, is that a true statement? Does 0 equal 0? That is true. And so the result here is that this is actually the same line. That would be graphically what's going on. So we don't have to remember that necessarily, but what this means is that there are infinite solutions. And if you know something about linear equations, it's a very similar result with linear equations. So it's the same idea here. Okay, so here is another one for you. So this is another one that I think you could either use substitution or elimination on. I tend to prefer elimination, but you do you. So I would recommend that you try this one from start to finish now using whatever technique you want. Hit play when you think you've got it. So like I said, I prefer elimination. So I am going to multiply this by 2 to start. Actually, by -2. By -2. So this is going to become -2x minus 2y equals +20. And then I restate my other equation. Okay, and so now I can try using elimination here. So I can go ahead and just add straight down. So this becomes x equals 32. Okay. And so now I can plug this back into either one of these equations. So I'm going to have 32 plus y equals -10. So if I subtract off the 32, I get y equals -42. And so 32 comma -42, that will be my solution in this case. Okay, so let's do another one of these together. Again, using any methods that you like, but go ahead and pause here. I'll tell you another funny thing will happen with this system. See if you can figure it out and interpret the result before I tell you. Hit play when you're ready. Okay, so once again, so I'm going to multiply this by -2. So I get 4x minus 2y equals -6, and -4x plus 2y equals 10. So now if I use elimination, 4x minus 4x is 0, -2y with plus 2y is 0, and on the other side, this will equal 4. Now, does 0 equal 4? Of course not. That doesn't make sense. And so if you remember from just equations, what this means is that this has no solution. And so what that really means from a graphical standpoint is that the lines do not intersect. Okay, so I have 3 more examples that I'm going to go through of just odds and ends with systems. If you're finding this content helpful, I'd love it if you hit that like button or leave me a comment and let me know how things are going, or hit the subscribe button. Okay, and so for D here, so now what we've run into is kind of an interesting situation. This is actually a problem where I would say substitution is not good for this one. So notice what we've got: 3x plus 2y equals 2, 2x plus 3y equals -2. There's no variable that's like super easy to solve for. So I would prefer not to use substitution for this one. Instead, we can use elimination, but what we can do is we can multiply both equations by something. So just completely arbitrarily, just because I feel like it, I am going to work on eliminating the x's. So I just want these to be opposite. So what I'm going to do is I'm going to multiply this first equation by -2 and this second equation by -3. So therefore, oh, sorry, not by -3, just by 3. So therefore I get a -6 and 6. And it doesn't matter which one you wanted to make positive or negative. You could have made either choice. So anyways, this is going to be -6x minus 4y equals -4, and 6x plus 9y equals -6. Okay, so now I'm going to add these straight down, and my x's drop out, and I'm left with 5y equals -10. So if I divide both sides by 5, I will get y equals -2, and then I can go ahead and solve for x. So this becomes 2x plus 3 times -2 equals -2. So this becomes 2x minus 6 equals -2. Add the 6 to both sides to get 2x equals 4, and divide both sides by 2 to get x equals 2. So my solution in this case is 2, -2. So for these last two, we're just going to talk about what do you do if you get either fractions or decimals. So with fractions, if you are familiar with fractions with equations, it's the same idea. So we don't actually want to deal with the system having fractions in it. We want to clear them. And so what we're going to do is we're just going to first multiply everything by the LCD in each equation. So for the first equation, as I look through all these fractions, the LCD in this case is going to be 10. And in the second equation, the LCD in this case will be 6. Now, I have a whole video where I have talked about using this trick at length. And so I will refer you to my video on solving linear equations if you want to see this technique broken out in a slower pace. But for now, I'm just going to use it. So what we need to do is we need to take the LCD times each part of this equation. So I'll just show you what that looks like. So notice I've taken 10 times each part of this equation, right? So that's what we see here. And so in doing this, what this allows me to do is then actually get rid of the fractions. So for instance, 10 times 1/2, what is that? That is just 5, so this will just be 5x. And then 10 times 1/10, those 10s will drop out, so I'm just left with 5x minus y. And then 4/5 times 10, there's several ways on how you can multiply this together. So you could think of this as 40 over 5, and so that would just equal 8. So this just equals 8. And then I'll do the same thing with the second equation, so I'll just jump to showing you what this is going to look like. So here it is, and so then it's the same idea. So 6 times 1/2 is 3x. 6 times 1/6 will just leave me with a y. And then 8 over 3 times 6, just to remind you of this other trick that you could use, you could alternatively think of this as 3 goes into 6 2 times, so then you're just left with 8 times 2. Again, those are all tricks that I talk about in one of my other videos, so I don't want to spend a ton of time on it here, but you can go back and check that out if you're interested. Okay, so look at what I've got now. I've got this equation and I've got this equation. So I would much prefer to deal with these two equations, so let's make some more space. So here's the system that I need to solve now, and I think what would be easiest for me is if I just multiply this first equation by -1. So I will restate this system. So this is -5x plus y equals -8 now, and this is 3x minus y equals 16. So I can add these straight down to get -2x equals 8. Divide both sides by -2, and I get x equals -4. And then I just have to solve for the other one. So let's see. Oops, sorry, this should be x equals -4. Sorry, my pen didn't work. Okay, so now let's plug this into, I'll just plug it into the second equation. So this will be 3 times -4 minus y equals 16. So this becomes -12 minus y equals 16. Add the 12 to both sides to get -y equals 28. And then divide both sides by -1 to get y equals -28. So my solution will be -4, -28. And for my last one, so I have decimals here. So the trick with decimals is that you just really want to move them to the right. So what you're going to do for each equation is you count the maximum number of decimal spots and then move all decimals that many. So for the first one, the maximum number of decimal spots is 2. So I'm going to move each one of these decimals over 2 spots. So this will turn into 3x plus 1y, so I'll just write y, equals 40. And then for this second one, so I need to move all of these decimals over 1 spot. And remember, this 2 has an invisible decimal, so I'll move it over here. So this second equation becomes 1x, or just x, plus y equals 20. And now we can do whatever we want to solve this system. So I think for me, I will just multiply this second equation by -1. So I'll restate the system. So this is 3x plus y equals 40, and -x minus y equals -20. So add these together to get 2x equals 20. So divide both sides by 2, and I get x equals 10. Okay, so now I can plug this x equals 10 into either one of these two equations. So I'll just plug this into the first equation, or second equation. So this becomes 10 plus y equals 20. Subtract off the 10 to get y equals 10. And my solution here will be 10, 10. Okay. So my goal is to keep these review videos shorter, but maybe now you feel like you'd like to try or see some more examples. So don't worry, if that's the case, I've got you. So every one of my review videos comes with practice problems. So the practice problems includes a PDF of problems with an answer key and also video solutions. So you can really see more problems in whichever way you want. It's all free at divideandconquermath.com. Just go to the review section. I will say this much, you really can't learn math by watching a ton of YouTube videos. You do need to practice it to master the skill. So feel free to use those other practice materials in a way that makes sense so that you can master this for whatever your need is. Also, by the way, my review series has many other topics in it, and each topic includes a refresher video, which is what you're watching right now, and then the practice problems, the answer key, the extra video worked out solutions, all that good stuff. So again, just go to Divide and Conquer Math, go to the review section. It's all free there. But anyways, I am going to leave it at that. So I will hopefully talk to you guys in another video. Thanks for watching.